I think first of all, the past named Poly has always been kind of part of LLVM. So Poly had been considered is quite respected in the loop optimizations area, and I don't know what mainstream etc. means. For example, even in GCC, there was some bunch of very successful loop optimizations called Graphite, but that morphed into exact dependencies and poly as well. We discussed this in the tutorials in the afternoon. And major challenges, of course, are in what is called the scope detection, scalability of the dependence analysis, or the detection of the programs, and then scalability of the transformation itself. Transformation sometimes involves, it could take quite an amount of time, which the compiler, which the user may not, it may not be desirable compilation time, but approximations are possible. Researchers are working on it. But beyond LLVM GCC, we discussed about MLIR just a couple of hours back. MLIR is one infrastructure where loop optimizations are supposedly more available, etc. So things are happening at a research level, but they are available as well. So maybe Govind sir can, because his group also has been working on poly, etc.
Yeah, I don't have much to add. These as techniques have been developed, there are these open source frameworks which are available for you to build on top of this. To what extent they have been applied to mainstream compilers, whatever you call as mainstream, is a slightly different question. But yeah, there are these techniques which can be applied at least with whatever whatever setting in which they are supposed to be applied to. I mean, there have been a good amount of progress over the last several years.
Yes, sir. Thank you. One small point is there is just a paper accepted in PACT this year. It's called Polygist. That's a very unique and nice infrastructure by which you can call either Poly or Pluto, the most famous two polynomial compilers from MLI infrastructure. And that has been that's a very nice framework. It could help really make polynomial comparison mainstream, if mainstream is double quotes, but that's what.
Yeah. Thanks, sir. Thank you, sir, for the direct answer to this. Yeah. So yeah, the next question is. I'm glad that I was able to learn so much in these 10 days, and so with all the concepts and resources which we learned from this school. In order to build a simple basic compiler, what would you suggest as a starting point, like the sequence in which one should proceed? Request the panel members to.
If I may volunteer Uday's name for this.
Yeah, please. Please, Uday,
sir. First of all, you have to ask yourself, what is it that you wish to achieve when you write such a compiler? Is it that you want to just get some idea of how the whole thing works, how various things interact with each other? Is that one thing? Or it could be that you have a different programming language in mind that you wish to compile. Or it could be that you want to add some optimizations to or passes to existing compilers like GCC or LLVM. So there can be many ways in which you can get into this. So some of the students I know had some domain-specific languages in mind for doing something very specific, and then they wrote Lexaniac scripts and generated code for it. That's one way. Or if you want to want to understand the traditional compiler pipeline, then you have to pick up material from any course. For example, let's say what Shubhajit teaches or what Krishna teaches or what I teach. You will find on our web pages when we teach the UG compiler course, we get students to implement the compiler. So I have, for example, a certain plan of implementing what I call SCLP, a language processor for a subset of C, where one can think of interpretation as well as compilation, and there is a very definite plan, and students are implementing parts of it. So these are the ways in which you can proceed.
Thanks for the pointers. Yeah, I will move on to next question. Yeah. What is the most common area of research in compilers and why? This by Jasmine. These are again independent questions. Maybe we can go over them quickly, and then we can move to the next question, next section after this. Yeah. So request anyone from panel member to answer this.
Okay, again, I'll actually answer the question in the following way. In the summer school, you have seen topics in different areas, right? Almost in all of them, right, there is active research that is happening. In fact, you have been taught by faculty who are working actively in one or other of these areas, right? So all of them are, common areas of research, and they are exciting. There are interesting problems to solve, and people have been working on that. This is the reason why they are common or most common. That's probably the most generic answer that I can give, whether it is program analysis, whether it is, like what they pointed out, whether it is interprocedural, flow sensitive, context sensitive, whatever you want to talk about, or it is polyhedral compilation, right? All of these areas, there are lots of interesting problems and people are working on that. So it's kind of difficult to pick one area and then say that this is the most interesting or this is the most common.
Yeah, I think that's like, and thank you, sir. So actually the next two questions are more or less related to that. I think maybe
the next question is directly to the
need of PhDs in compilers and systems domain in general. Dibripan, do you want to answer?
Sure. I certainly need PhDs in compilers.
Yeah.
No, I think hearing from you, people will be more convinced than hearing from any of us. That's the reason why I directed it to you.
Yeah. No, let me sort of answer it this way. I think that there is a need for PhDs and researchers in compiler domain for multiple reasons. I think there are a lot of interesting challenges to solve in the industry side. As I mentioned before, entire new gamut of applications are opening up, and system innovation is one of the key ways to stay ahead in this thing. So a lot of companies are actually looking for compiler people. So suddenly there are lots of different types of processors. There are lots of domain-specific languages, and there is lots of need of compiler people, researchers as well as engineers, and any kind of skill mix in between those. So I think that it's a very active field. We need a lot of people in the industry side. And also, I think the same reasons are gravitating a lot of researchers to look at these systems areas, right? So even if you want to be a pure researcher and want to look at academics as your future, I think that these areas are, as somebody said before, evergreen and ever challenging. So so that would be how I would look at it.
Yeah, thanks, Divyapran. That's helpful. Yeah, so I mean, the next question is, I think most of the speakers will say yes to that. I mean, mostly you might have found the answer by now, but anyway, I'll just read the question again. Can you speak about research groups in India and abroad who work on compilers and are taking master students the coming year? But not the coming year, maybe because it's difficult for the professors to check that. But I think in general, all the speakers who gave talks for you during the session, they take students. Anyway, I request the panel members to answer if anything specific that you have for this.
See, we are always in search of people who are interested in compilers. Okay, so all of us here on the panel, we would be eager to have you work with us, come and join our institute, and we would welcome you with open arms.
I think the number of compiler groups in India have increased in the last 10 plus years. It was Lone Battle, I think Uday was doing in IIT Bombay, and Srikanth and Preeti Shankar were doing in IISc. But now it has increased, and we have Krishna, Ramakrishna, Subhajit. There are also other people in IIT Kanpur like Abhay, and IIT Madras we have Rupesh, and Delhi we have Saurav Bansal. So there are so many people. And IISc now we have another Uday Reddy, who works in polyhedral compilation. So there are many faculty who work in compilers and related areas, and they are all interested in hiring students. And there are lots of exciting work that happen in compilers across India. That's one thing that has changed in the last about 5 to 10 years, if I can say so.
If I may say, it's not out of place to mention the Indosys initiative taken by Professor Govind sir around 5 or 6 years back to keep the systems researchers together in some way or the other, because that was a very commendable initiative, and I think this is still we eventually we should have a more Indosys meetings, so you can please look out for this aspect.
Yeah, thank you, sir. And so thank you for the special mention, Ramakrishna. So anyone want to raise their hands? Actually, I'm not able to see. Shall I move to next question?
No hands raised. No hands raised.
Yeah, thanks. So while writing LLVM passes, I really astonished by the...
Aditya has raised a hand. I can see that.
Right.
Yeah, please, Aditya, go ahead.
Hi, Professor Ramakrishna. This Indosys initiative is very exciting. I was not aware about this. Can you please share more details about it? I mean, offline maybe, or in the call.
Yes, I will. It's a initiative when the Indian system researchers, it's like they conduct these workshops, etc. And it's happening. I'll share the initiative and I'll share the link.
Thank you.
While writing LLVM passes, I really astonished by the fact that how things are getting handled by such a large code basis, around 8 GB. How should one approach to contribute in this domain of compilers as a beginner?
This is a very easy to answer question. Approach any one of us. Most of us are doing something or the other with LLVM. Ramakrishna certainly, Shubhajit, and even my students are now working in LLVM. And there are interesting problems that we are doing in LLVM. So just approach one of us and we'll be happy to have. I mean, for example, we have Shreya here, who is my intern, who's doing something in LLVM with me on pointer analysis. So there are plenty of things that can be done. The only advice that I would give is, instead of trying to do it completely on your own as a freelancer, it's better to connect with someone who's actively working on it, and then you know what the real problems are. Then you also, some kind of hand-holding can also happen, and then you can figure out what is it that you like. There are lots of things that you can do. I mean, it's only limited by your imagination.
Yeah, I would like to add one point here. I think it's quite common to be sort of intimidated or overwhelmed by large code bases, So whether you work on an infrastructure like LLVM or GCC, or you join the industry and you find that you are certainly looking at a very large code base with lots of complexity inside it, and how do you cope with that, right? As Kirkar sir mentioned, there are a lot of experts whose guidance you can get interesting problems to solve. But looking at, simply trying to cope with a large code base, I would suggest that, look at it in sort of two ways. One is develop high-level block diagram picture in your mind that, what are the major blocks in this LLVM compiler? How do they connect? which one comes after which one, and how does it all make sense, which phase does what. So develop a 20,000 feet view of the compiler infrastructure, and then go into one of those blocks and actually try to write some code, some significant part of the code yourself, right? So you could take a small portion of the optimization space, maybe one pass, and completely rewrite it yourself. Try writing your own loop unroller and see where it lands you. Does it perform better than the standard unroller in certain cases? Does it perform worse? Why does it perform worse? At the end of such an exercise, you will have the you will be able to claim that I know quite a bit about, loop unroller through this exercise. So developing your competency in the code base by first, going breadth and then depth is one of the ways you can deal with this large code bases, which often feel very overwhelming.
Thanks, Uday. Thanks, Divyapran. Actually, you gave a nice structured way to go ahead with the large code base.
May I add one more minor point?
Yeah, please go ahead.
Yeah.
See, at
Yes,
some point, the answer to Aditi's question is you really pretty much never will understand the whole of the compiler, the whole of the OS, if it is of any reasonable size. I mean, these are really large softwares. And it's perfectly okay. There's nothing wrong in that. You will get a high-level view of the whole thing, and then you will kind of slowly learn about, like an onion peel, different layers. And what DP said, Divyapran, about the breadth and the depth cannot be understated. I think it's worth repeating. Do not try to think that, okay, I'll go deep into, I'll learn something very deep, all the corner cases, all the sub cases. Don't go like that. Go bit of depth, bit of breadth, bit of depth, bit of breadth in a onion peel fashion. And it's okay if you don't understand everything. And like Professor Uday mentioned, there are many courses which are available both within India. I mean, many of us have courses where you can develop a complete compiler in a much more simpler setting. That's what we call as academic setting. If you go to real world, what DP is talking about, then that's where you'll see a lot more, or LLVM or GCC or OpenGNI and any of these. There are a lot more corner cases, and that's what makes it a real world compiler and also very challenging. So don't get psyched. It's okay if it is daunting, but you can slowly learn it in a stage by stage process.
So I think what you have to do is you have to learn to appreciate two things: A, the beauty of compilation, and the enormity of compilation. You have to look at both the things. Sometimes you might just focus on the beauty. Sometimes you might want to just focus on the enormity and do a structure and all that. Then it becomes easier to navigate your way through the maze of a very large code base. For example, we built lots of courses on explaining GCC for several years. From 2008 to 2013, we were running those courses. So it's all possible if you can do it in a structured manner.
I totally agree with Ramakrishna here. So I agree with Professor Mandivada as well as Uday Ketkar, sir. So all these universities, they have very good compiler courses. For example, we are using Tool, but in addition to that, in our place we have a Introduction to Compiler Engineering course, where the entire it's a lab-based course where students have to write a couple of analysis classes as well as transformation classes. This has been reasonably successful. The students are reasonably confident. It has resulted in some number of PSOCs and open source contributions. But in general, it's doable. The confidence is correct, and like Nandivada said, it's like peeling an onion. Some amount of bread, some amount of that really get you through the thing, and with the belief that there's no necessity to probably you cannot expect to understand every line of a code base as big as GCC and LLM, etc. And that's okay. It's the moment that is accepted, we are well.
Yeah, thanks, Ramakrishna. Yeah, thank you all for the answers. So actually, so Ramakrishna, how are we on time? Actually, it's I think 1.5 hours. I mean, it's really important. Like students' questions are getting answered, and I am not feeling bored at all because I am also learning, and interesting insights are coming out of this discussion. But do you want me to go? I mean, pick some questions, or shall we go in the same fashion?
I think I would prefer to continue, but I will request the esteemed panel members to comment on this.
But I also feel members like Unni, Jyoti, you have also done some.
I agree.
A lot of work in this fashion, in this direction, and do share your experiences as well.
Yeah, sure.
Jyoti, how many more slides do you have or questions do you have?
So actually, in the second section, these are the 4 questions.
Okay.
Sir. Actually, this is about this one, and then ask me anything or general questions, 2 slides, and then these are actually more specific questions which are targeted to some actual topics. I think they have learned during the session about optimizations and about the IR technology.
Okay.
So these are very specific to how to apply to PHP project and more on the compiler optimization with respect to programs and things like that. So we kept those things at the end because that might require a different setting to answer. So
some questions that are very specific and detailed can be skipped for the panel. Yeah, can be skipped for the panel. Some general questions, maybe. Yeah, I think section 2 and section 3 can be taken perhaps.
Yeah, sure. Thank you. Okay, we can go to the next section. So this section is.
Can I talk for 2 minutes?
Yeah, yes. Go ahead.
Yeah, please.
So since there is a discussion on this ML in compilers and compilers in ML, I just would like to mention like this compiler design handbook, which is from Professor Priti Shankar and Rajan Shrikant. So it's a chapter on statistical machine learning techniques in compiler design, where this concept like which somewhat what Subhajit mentioned, like even few more terms I would add, like adaptive compilers, So it has one chapter discuss about how ML techniques can be applied in compilers, and going to the reverse direction, like compilers for machine learning, like if you look at NVIDIA, it has already come up with TensorRT, like the compiler like TensorRT. Then there are other compilers like Intel ngraph, PlaidML, where they are typically used for deep learning applications. So the recent ones, and just now I find publications from this UT Austin look like graph neural network and so many things. So now I think the direction is going towards systems plus ML. There are like a lot of publication happening, like even this TVM compiler, like Auto TVM, it is typically used in Qualcomm Hyderabad, and like I guess Ramakrishna also knows, because Ramakrishna also knows, I guess. And so there are compilers which are used for even like in the same way like Subhajit mentioned, where you have to find a best program for a given hardware. Like you run it on a server like a computer, and you have a specific ASIC or application specific integrated circuit where you want to find the optimal performance or optimal code for that machine. So in that cases, like Auto TVM, these are used. So there are many domain specific compilers just related to ML happening. And yeah, that's all I want to share on that aspect. Sort of spending 2 minutes in conversation. That's all.
Yeah, thanks, Krishna. Actually, you mentioned a lot of newer frameworks like TVM and all. Thanks for that. Actually, they'll be useful. Yeah. So what I'll do is I'll just go over these general questions, and then we can take up the other ones. So the first question is, what are the career options in compilers and systems domain in general? I think Divyapran partially answered this. Like again, we can discuss again.
So let me just start with the following things. Like every big company that you know today, right? They would be hiring compiler people if that is what you are looking at, and every university is willing to hire compiler people. So whether it is Google, Amazon, MSR, whatever you want to talk about, they all require compiler design techniques to be applied in some place or the other. And there are plenty of opportunities for compiler designers, not to mention a huge number of course, I missed out on NVIDIA. NVIDIA would also love to hire compilers. And a large number of interesting startups are also looking for very good compiler designers. So there is no dearth of opportunities here.
Yeah, and there are there are a lot of new ways of applying compiler technology, like in security analysis or other say source to source translation is also something that a lot of companies rely on, source to source translation technologies. So, but broadly speaking, as Professor Govind mentioned, all companies which have a processor, a semiconductor processor kind of a environment, are looking definitely for compiler engineers. I can certainly speak for NVIDIA. We have now a very large compiler team. Worldwide, we are about 300 people and growing. So, I think most big companies tend to have a requirement for a lot of compiler engineers. So the field is very vibrant.
Yeah, thanks, Divya. And actually, thank you, Govind sir. Also, I mean, I just want to add one point here. Like when I completed my PhD, initially I used to have this feeling of, okay, maybe compilers is a very narrow area. Will I get? I mean, what kind of opportunities will I have and all? But at the end of my PhD, I realized like I had like so many options. When I was getting offers from different places, and also I was able to also apply different places. For example, NVIDIA is one, Intel, MSR, Google, all these places. So yeah. What is the most exciting area of research in systems with respect to opportunities in industry and funding for academic positions?
All areas. I think we should not be. We shouldn't be working on which one it is. I think every aspect of things, like in compilers, we mentioned all the areas that many of us are working, they are exciting. Similarly, if you look at in systems research, there are many topics which people have been working on. It's impossible to list all of them over here, I would say, right?
Any other comments on this, mostly with respect to the funding for academic positions and all? From other panel members?
Again, it's my feeling that there are plenty of opportunities for getting research fundings. There are targeted research problems that industry is looking at, which they are willing to fund. There are government agencies which are willing to fund. If you're looking at systems area in general, as well as compilers in particular, there are plenty of opportunities for funding. I don't see that to be a problem. It's actually, I would say, the bandwidth is the problem. The amount of, the human resources that we have in this area in India is the problem.
Yeah. I think that's a very key point, because for any field to grow, you need a critical mass, right? And I think that there are lots of there is a small but very motivated community of compiler researchers and engineers and developers in India. But I think for really it to take off, we need newcomers to sort of join this pool, so that you get that critical mass in terms of both the industry as well as academic, and it's both sort of feed on each other for its success.
So I would just touch upon the funding aspect. Funding is usually a function of the perceived usefulness of whatever you're doing. Sometimes if you are solving exactly a problem that an industry wants to solve, I mean, DP has lots of problems to solve. You go to him and say, I'll solve this problem for you, and he'll generously give you a lot of funding. But if you are working on some other problem which are not directly relevant, maybe indirectly they can be used, then you have to look at some other funding sources. So it all depends upon exactly what kind of work you're doing. I mean, eventually everything is useful, but is something directly useful tomorrow, then you have a lot of funding. Is something useful maybe 5 years down the line or 10 years down the line, then you have to try a little harder for funding. You have to go to government agencies for funding, etc. So that has been my experience.
Thank you, sir. And also you have definition for all, like you have definition for funding as well. It's nice. Yeah. So yeah, let's move on to the next question. It's about, I think this question is partially answered already. This is research opportunities in industry and academia versus please explain positives and negatives of both. Maybe I think this question is mostly not, maybe the opportunity part is already answered. Maybe I think the experience part can be taken, like what's the experience in academia and industry. I think the panel members can give the comments.
I can talk about the industry. I think my understanding is that in the industry, basically, what we end up focusing on is multivariate problems. So it's never the case that we can look at one problem in isolation, but we have to look at it in context of multiple other parameters, all of which we need to be optimized, right? So to give you an example, say you are trying to build, alias analysis into your compiler. You in the industry, knowing that your customers may have, 2 GB of source code, you will have to take into account compile time and the efficacy of the generated code as 2 parameters, and you'll have to constantly trade off between them. So you cannot just select an algorithm which is very good in one but really poor on the other factor. So then you can add other variable, other sort of parameters to this, like say for example, how debuggable your code is. Is it maintainable, right? Because ultimately in the industry, a lot of people will end up working on it. There'll be a lot of different use cases. Is your final implementation so complex that it is hard to get it right? So a variety of factors influence choices when you work in the industry side, and that makes sometimes makes for a really interesting problem to solve, and at other times it can be really frustrating because you end up saying that how can I optimize on all these counts, right? So that's the balance and the tightrope walk that you end up doing in the industry. And maybe other professors here can really comment on the challenges in the academia side, I think, to contrast.
Hello.
I'll add something quick in the interest of time. When people ask what is the most exciting area, any area that you like is going to be the most exciting area. I mean, how about this? The oldest languages, right? Some of you might have heard about languages like B, right? The precursor to, which was a precursor to C. That's also still used. I still remember one of the questions that used to be asked to us: if you want to learn one language, and you're a jobless person, you want to learn one language, which language would it be? You'll ideally say, okay, the language in which maximum hiring is done and which is paid max. Can you imagine it still? I mean, COBOL is one of the most profitable languages to learn. So nothing goes out of work. There are people who keep on using. If you like something, you will find it exciting. And in the systems area is one of those which is kind of going to remain evergreen. So, I mean, all these things that keep come and go, right? I remember during my PhD time, networking used to be cool. then it became security, then became something else, then now I think it's ML. These things will keep on changing. Don't worry about just, oh, I mean, should I only go in the hottest area? All right. So life is much more longer than the longevity of the hottest areas.
Let me add something to what Divya said, more from the academic perspective. So in the academic setting, we have the luxury of looking at the problems that we like, and we have the luxury of setting our boundary conditions the way we want to in certain reasonable ways. And we also have the luxury of being able to study problems which are very challenging and could potentially be useful down the road. These are things that we are able to do, or these are the luxuries that we have. So sometimes these kind of you are away from reality in some sense because of some of these things, but nonetheless it gives you wonderful opportunities for you to explore and do things. And again, sometimes you are limited by the size of your group, because if you may want to do a really challenging problem that involves involvement of large groups, which you may or may not be able to set it up in your research group, that there could be challenges from those fronts, but there are definitely opportunities that you get to do. That's what I like about the academic setting.
Yeah, thank you all. Actually, I agree with the academic setting point that you have more freedom, and also regarding the opportunities in the part in academic setting. Actually, here also the people are looking for compilers people. There are a few compared to the overall faculty members. Actually, there are many newer IITs also has opportunities. They're looking for compilers people to come and join. So you have multiple opportunities. Don't worry about that part. Yeah.
Yeah.
So the next question is some possible directions for upcoming startups in compilers and systems domain in general. Any panel member want to take up this startups question?
We mentioned this, if I may take this, we mentioned this in one of the parallel compilation tutorials as well as lecture. So there's a lot of startups coming up. They have domain-specific architectures, and then they, for specific purposes like they have an FPGA, they have a they want to build a compiler, but that I don't know, there's some image recognition for something, traffic and number recognition, number plate recognition, etc. And then they are really looking for a compiler system that will cater to that. So in general, this is a very open space. This is a very exciting space to be in compilers right now, because they read compilers, and then compilers. He's happy to be in this position. Okay.
Thanks, Ramakrishna. Any other comments on this, or shall I go to next section? Yeah, I'll move on. So yeah, these are more general questions, and I think it would be helpful to help the young students. I mean, these are mostly, I can see these questions are coming from the newcomers to this area. Yeah, let me read out the questions. What role India and Indians need to play to get best of emerging field? I think it's more general. So, Siddharth, can you please elaborate on your question? Emerging field, do you mean is related to compilers or?
Yeah, it's about compilers and systems.
Okay. Yeah, any panel member want to?
Okay, so let me try to answer the question in a slightly different way. As researchers, we try to look at interesting problems and try to see how we can come up with interesting solutions or effective solutions for them. And oftentimes you try to look into a particular sub area in which you are interested in and trying to solve in challenging and interesting problems in that. And if you're able to come up with good quality work in that, then you make an impact. Right? This impact may be a delta or maybe a small impact because, again, in terms of the numbers, we really don't have very large numbers. For example, if I compare any Indian university or any Indian institution with a university elsewhere, in terms of number of faculty in a particular area, in terms of number of research students in a particular area, we are doing extremely small. And then this is also kind of spread very thin across maybe about 10, 15 institutions in the country. So to think of making an impact like what some other country would be able to do in an area may be difficult, and it requires a lot of other things to be done in the first place. But let's not worry about it. What we can do and what we should definitely do is that in the areas in which we are working on, we should try to make an impact in terms of the quality of work that we are doing, in terms of the the problems that we are able to solve and the solutions that we are able to bring in. I think that is more important rather than whether this impact has been as big as somebody else. And this is purely a resources problem, if I may say.
Yeah, thank you, sir. Actually, that's helpful. We always have this question of, at least in the initial stages, we want to make big impact. Then working on these specified problems actually sometimes is a concern.
Yeah. The only thing I would like to add is that focus on building software, right? See, I think the world today presents challenges, but also new opportunities, right? Like just this conference here, we are all sitting in our homes and attending this conference. I'm sure we can similarly attend conferences and learn about new technologies somewhere else in the world, which even 2 years ago would have required physically going there and then only getting access to that information. We have a lot of information out there today, which we can use from any part of the world, right? I think what's most impactful is somebody just sitting down and trying to develop software and putting it out there and develop. As you get onto that train of developing more and more software, you end up doing something which a lot of other people will further use, and as a sort of, it has a cascading effect of bringing more and more goodness, and more and more people get excited about it, right? So I think I would say that build, or do. That I think is the easiest to do and has the best impact.
Yeah, thanks, Dibyapran. I think that makes sense actually. Yeah. So the next question is, I think the next two questions can be taken at the same time. It's the advice for the newcomers to the area and how to enter into this particular field, right? So Bijit, you want to take? I did not hear you from class.
Okay.
Sorry.
No, thank you. So research is something very different. So what I'd suggest is that join a good university, get started on that. That is one thing. The second thing is that, do you want to do research? That is the other part. Like Dibyapran said, build software, right? So now the good part is that there are a lot of open source opportunities. There are the LLVM is a completely open source software, so you can start contributing to these repositories. You can look at new create new GitHub projects, advertise your projects. That is a very good way of attracting people and saying that you are doing some interesting things. And people, even if you are looking for a career opportunity, either in industry or in academia, that's a good, a project link is a very good thing on your CV. So that is one way of newcomers to really get into an area of their choice and attract people, interested people, both in academia and in industry.
Yeah, thanks, Srijit. Any other comments on this?
I would also add that be courageous to follow what you like to do, right? So at certain points in your career, you'll come across, okay, I have this another job offer, which is in a field that I'm not so interested, but it sounds like a really good pay or a really good company, and I can't just refuse that. So I'm going to sort of give up my love for the subject that I really like. I think that's not a bad decision, but if you stick to what you like doing, eventually it leads to a lot more of job satisfaction, or whatever, when you look back. And I think everybody on the panel can attest to that fact, right? So be courageous to follow what you really like to do.
I think everybody you see in the panel is doing that. That's right.
Yeah. Yeah, it's inspiring. I mean, you can take them as inspiration. Yeah. The next question is, for a person beginning in the field of compilers, what path should one follow to explore and research in the field? What path, meaning, I could not understand. Aditi, can you please elaborate? What do you mean by this question?
Actually, ma'am, it got covered in the last answers. Thank you.
Yeah, sure. Thanks, Aditi. Then I'll move on to next question. What advice for choosing academia versus industry would you give to someone who wants to get his PhD in programming languages?
So if I may say something, I mean, I missed some part of it because there was a rare power outage at our end. I joined on phone. So I would like to give one advice, not just about PL in general, but about research, and also about whether you join industry or academia. So I have been giving a talk on what is research, and there's a video on the YouTube. So if you go through that, many of your questions are likely to be answered. And if you are unable to locate it on YouTube, just send me an email. I will be happy to mail the link to you. So there are lots of such issues which the students have answer questions about, and you might get answers to many of those questions. So I will not elaborate on all of them right now here, but you can look up that talk.
Yeah, thanks. I think I also saw, listened to that video. I think it's really helpful, actually. I think you should definitely go and see the video. It will be really useful to you. We'll move on to the next questions. So I often struggle to reach out to experts in systems for doubts in different parts which I'm not competent in. For example, if an idea in microarchitecture design can benefit from compiler support, I do not know who to reach out to, and sharing paper authorship is not a problem. Finding the right people is. Is there any way to overcome this challenge?
May I go ahead with this?
Yeah, please, sir.
The answer is simple. Start. Write to the people. If you want to write to someone, just write. Even the next question, I read through the next question as well. I mean, the hesitation is more in your mind than on the other side. Just write. There's no harm in writing. People are in general very open to collaboration and discussion and all that. Just be open. Don't be afraid. Most of the people on the panel or in general faculty, we are not cannibals. We definitely don't eat up people.
Okay, so I would like to add something to it. It's important to write, but also you have to keep in mind that what you write should be of general interest to the receiver. So what helps a lot is if you have done some work on it before, and if you've done a bit of homework on what the person is doing, if you ask the person what are the problems that I can work on, then there is a very good chance of you getting a response. But if you ask that I have this idea and I want to develop this, sometimes what happens is people are very busy. They may not want to deviate from what they are doing, so they might just write a polite email. So the best thing is, at least initially, to become an apprentice of an expert, to become an intern of an expert, and then you can really get a very good time and very good advice from it. So I also keep getting lots of emails. Sometimes what happens is many of those emails are of superficial interest. So you have to demonstrate that you're serious about it. And that is very, very important.
Yeah, thank you, sir. Thank you, Vishnu, sir, as well. So I think this is an important point. I think most of the times we miss opportunities because of that hesitation. I think thing is to just write. In the worst case, we may not get the reply. That's all, right?
Yeah, and do some homework. Doing some prior homework before writing is very, very helpful. That can guarantee you a response, because most of us are looking for people who are keen on these things.
I mean, just to add, right? I mean, so many times we get mails that look like, "Dear Sir / Madam, I'm interested in architecture / DBMS / networking. I think I have seen your work, which is related to this. Give me a slot to work." I mean, this clearly shows they are writing generic emails. These things won't fetch any response.
So let me add one of the experiences. Maybe I'll take a minute to describe it. So I have one intern currently working with me. So it so happens that this intern just looked up live variables analysis problem in the GATE syllabus. So she looked up on Google. She happened to find my YouTube videos, and then she thought she was interested. The problem was interesting. She thought she should implement it. So she looked for where to implement. Then she came across LLVM. So she downloaded LLVM, built it, and wrote a pass in LLVM on live variables analysis. And then she wrote me an email describing everything that was done. And I was very, very impressed. And I'm happy to say that this intern is one among the audience right now. Shreya Singh is the intern, and she's really picked up things very well. And because she had done her homework and approached me, I was very happy to spend time with her. We need people like this.
Thank you, sir. Actually, that email definitely deserves an answer after a lot of homework from her.
Yes.
So yeah, Ramakrishna, I think this is the question that you can take up. So it's in one of the sessions, Ramakrishna sir mentioned that some of the GSOC projects are also working in this domain. So can I get some insight about how one should approach to contributing to them as well?
This has been answered. I think, for example, Aditya's question, and I talked to her as well. What you call, you have to begin slowly and then get some experience. What LLM is, etc., and then get start like Anandya said. So I think it's doable. Okay. So if you have any further questions, let's contact anyone, not just me, but any of the faculty members. They can help with this. It's doable.
Can I add something?
Yes, please go ahead.
Yeah, please.
So, I was part of the organizing committee of this LLVM performance workshop in CGO 2021, and in that one of the students I was mentoring from NIT Calicut was interested in my project, and finally I told him to apply in Google Summer of Code. And then before this LLM performance workshop was done, I told him to apply for Google Summer of Code, since he is very passionate to learn. Like, with whatever input we give, he immediately picks up everything. Then he applied for Google Summer of Code, and then he got selected. Then his BTech project was presented in LLVM performance workshop as part of CGO, and currently he is working in NVIDIA compiler team. He was initially selected in Oracle. After this much effort and his resume become good, and he's currently working in NVIDIA compiler team. So, like, if you are passionate, things are possible. That's just giving him my personal experience. Like, and just into this IIT academia, like only around 2 years, but I had such a good experience in these 2 years. Like, he was an NIT Calicut student. He came and approached me like, "I want to do in compilers. Can you help me?" Then his passion was like, he was very passionate. That's what I'm saying.
Yeah. I can second your thoughts, Professor Unnikesh. I think I'm very happy to have that said individual in my team. And the same things that you mentioned really impressed me as well, that he wasn't afraid of going against the current trends to follow what he wanted to do. And he actually, it's very unusual to see a BTech student go to another professor in another college trying to really address his or her desire to do a project in a subject that they like, and that's really impressive. We do offer internships as well to a variety of students to work on different projects, and it's this motivation and the desire to work in something um, demonstrated in the actions that you have taken. Like Ketkar sir mentioned that Shreya was able to demonstrate that she had taken action, right? So I think that's, if you have that, you already you have biased yourself for selection, is what I would say.
Yeah, thanks, Unnikrishnan and Divipran, for adding that, actually. So I think it might now have given pointers to all the newcomers what you have to do. Yeah, the next few questions are more general. I'm not sure, Gautam, maybe you should tell what you wanted to ask. So it says compiler design, how we carry out in regular project. So is it similar to what Uday sir was asking, like that you can go and see the pointers on these courses that are happening in different IITs to start with, or is there anything more you want to listen to? Gautam? Hello?
He's type of something. 1 minute. We read it out. Okay.
I think you can move on to the next question.
Yeah,
Yes,
the next
It's not
question.
direct. Yeah.
Yeah. So can you tell us how to identify good programming languages? Okay. I think it depends on the domain. Mayur, do you want to also elaborate on your question? So you're saying programming languages with respect to usage, or?
Yes, ma'am. I would like to add some thoughts to this question. Basically, I have written many articles from people, and they claim that this X language is really better. I have seen many languages, and I've written code for 30 years and so on. They don't really explain why that language is better than the other languages, but they swear by life that this language is good. And often, you know, if I explore Google, if I search for a language for a specific domain, there are lots of languages. If you take scientific computing, Fortran has been there for a while, but languages like new languages like Julia and Python, which are other newer languages, they are people often comment on such languages that they are expressive as Python, and I mean it actually gives a performance just like C. So that's often confusing.
If I take the question, I mean, so Mayur, I think you answered the question yourself. But before that, let me say that I think Krishna also already mentioned that the best language is COBOL. So let me start with that. But I think you already gave the answer. So there are two parts to a language, right? One is expressibility, which means that how well can you express the whatever task you want to do, and the other is performance, that how good is the performance of this particular language on the architecture that you want to run it on. And that is why most often what is the best language or what is a good language often depends on your requirement. And that is why there have been like so many languages sitting around. So that is why there is no best language. Like if you're talking about, again, for example, C is probably the most performant language, right? But the problem is, why is it not the best language, as everybody else would think? That the reason is that it is not as expressible as a language like Python. Something like Julia tries to bridge the gap by saying that, okay, I can give you expressibility which is similar to Python, but at the same time I'll give you performance which is close to C by sort of compiling it down to native code. So yeah, so this is a game. So you have to define, like if you're doing scientific computing, if you're doing machine learning, then probably you might choose a different set of languages. If you're doing some business analytics or things like that, you might want to do a different sort of language. And so it all depends on what your requirements are. So if you really care for speed, then it's a different language. If it's more about like maintainability and writing code that like others can understand, so in that case, you'll probably go for a different sort of language. So it all depends on your requirement of what you want to do, and that requires a very careful introspection as to like looking at the task and really understanding that what is the best language to use for this given task.
Thank you, sir.